Slide a number 12 hose clamp over the CPVC stub of the leveling joint, then feed the anemometer cable through the joint. Seat the anemometer cable on the CPVC stub. Take one of the 30 cm lengths of 1-inch PVC pipe, feed the anemometer cable through it, and seat it in the elbow joint. Set the subassembly aside. Now repeat the process with the wind vane using the second 30 cm length of 1-inch PVC pipe. Insert the two arms into the 1-inch PVC cross swivel joint, feeding the cables down through the center. Slide another number 12 hose clamp over the CPVC stub of the center leveling joint. Feed the light sensor cable through the joint and seat the light sensor on the stub. Set the subassembly aside. Insert the 60 cm length of 1-inch PVC pipe into the 4-way T. Feed the rain gauge cable through the pipe. Attach the rain gauge base to the cable. Attach the rain gauge base to the swivel and tighten the swivel nut. Add a 1-inch PVC T to the other end of the PVC pipe, feeding the cable upwards. Now add the 115 cm length of 1-inch PVC pipe and continue to feed the cable through. Add the radiation shield to the swivel joint by feeding the cable in and upwards, then secure the assembly with the lock nut. Press the bottom of the swivel T onto the top of the 115 cm PVC pipe. Slide the 25 cm 1-inch PVC pipe over the two cables and into the top socket of the swivel T. Dig a hole approximately 50 cm in diameter and 60 cm deep. Place a 2.3 meter long, 2-inch diameter galvanized iron pipe in the center of the hole. The iron pipe should protrude between 160 and 180 centimeters above the ground, no more than 180 centimeters. Fill the hole with concrete using a spirit level to keep the pipe as close to vertical as possible. Bring the lower subassembly to the metal pipe. Align the radiation shield as desired, then secure the lower subassembly to the metal post with two large hose clamps, one on the radiation shield T and one on the rain gauge arm T. Don't make it too tight yet. Fit the 4-way T onto the lower subassembly, feeding the radiation shield and rain cables out through one of the side sockets. Place the upper subassembly onto the top of the 4-way T, feeding the 3 cables down and out the same side socket as the rain and radiation shield cables. There should now be 5 cables emerging. Thread a 4-inch hose clamp over the 4-way T in the metal post and tighten it enough so that it holds the upper subassembly in place. Don't make it too tight yet. If the metal support pipe is too short so that the 4-way PVC cross cannot be clamped to it, move the large hose clamp down to the 4-way PVC T and then glue the T to cross joint so that the wind arms cannot rotate. Adjust the height of the upper subassembly so that the center of the anemometer cups is 2 meters above the ground. At this point, some consideration should be given to the orientation of the station. The wind gauge arms should be perpendicular to the prevailing wind direction, and the frame should be mounted on the upwind side of the metal post. Dig out a narrow trench directly below the four-way T for the rain gauge, approximately 50 centimeters by 20 centimeters by 30 centimeters deep, not shown on camera. Insert a 10 centimeter length of 1-inch PVC pipe into each of the 2 open sockets of the rain gauge four-way T. Add 1-inch PVC 45-degree elbows to the end of each. Add 2 40-centimeter 1-inch PVC pipe extensions that reach down to the bottom of the trench. Remove the legs and glue everything together with PVC cement, then return the legs to the rain gauge arm and backfill the trench with the soil that was removed. Now attach the data logger box to the frame by sliding the upper support over the leg of the four-way T, feeding the cables into the box. Tighten the hose clamp to secure the box to the four-way T. Slide the large hose clamp of the solar panel mount around the metal pole and then tighten up the clamp. Adjust the angle of the solar panel and then tighten the 2 number 20 hose clamps to lock it in place. Now feed the solar panel cable into the four-way T and out into the box. Insert the cable seal plug into the four-way T. Return to the rain gauge and level the base of the rain gauge using the bullseye bubble level. Tighten its lock nut while making sure that the base remains level. Add the rain gauge bucket and make sure the magnet is over the sensor. Add the rain gauge cover and funnel and secure with 2 small locking screws. Add the vertical filter to the funnel, followed by the filter screen. Add the rain gauge funnel elbow support. Ensure that everything is aligned, leveled, and glued, then make sure all hose clamps are tightened and secure. Return to the data logger box and connect the solar panel cable to the battery pack charging port. Connect the 3 I2C cables into the open ports of the quick multi-port connector, wind direction, radiation shield, and light sensor. Repeat the process with a second multi-port connector, this time connecting the cables from the 2 digital sensors, anemometer and rain gauge. The instrument cables are now ready to be connected to the data logger. The loose 100mm quick cable attached to the multi-port connector for the I2C sensors should be connected to the I2C port on the data logger. The same can be done for the digital sensors, but to the D22 port if using a Pi, or the A2/A3 port if using a particle.